So I'm not going to run through my full pedigree, but I did want to say a few introductory things about this. I had the harrowing experience of appearing in the Land and Environment Court a decade ago here, which Matthew Lawson reminded me of, that there were 6 different experts, and in the judgment it complains that there were 7 different opinions. And I'm somewhat loath to come here again and say what I think because of the problem of muddying the waters. And so to illustrate that, I'd point out that Paul Comar has already been here and said what he thinks. And I was asked to come back again after the Environment Court hearing to have a look at things that had arisen since the Four World Bayview proposal, and part of that involved reading in some detail Paul Comar's report, which I'm one of 3 people now to have read it cover to cover. I suspect it's very comprehensive and it was very useful, but I don't agree with it all. Those of you who've met Comar will know he's a thorough gentleman, and I like him a lot personally. Particularly after he examined my PhD in 1983, and therein lies the first conflict of interest, is that it's a very small area of expertise, and we all know each other, and incest is just rampant, really. And in Paul's case, it's particularly a problem because he wrote the shortest of my PhD reviews, which started off with the sentence, "This is the best PhD I've ever read." And given that it was so short, I took from that he hadn't actually read it. He'd been very busy and decided to be extra efficient. Anyway, for what it's worth. The last time he and I worked together was on this Columbia River littoral cell coastal erosion project, which is worth raising because apart from the Dutch, more money was poured into this research project than has ever been poured into any erosion project, to my knowledge, before or since. Back in the day, which was late 1990s, $5,000 when the Australian dollar was sort of like the peso compared to the US dollar. So it was a lot of money. And of course, at the end of the project, they knew that they knew less than they did before they started. Such is the nature of the science. Anyway, Comar and I were both assessors on this project to provide advice and feedback on whether they were spending the money prudently or not. On that project, Peter Ruggiero was one of Paul's PhD graduates, and George Kaminsky, who ran the project for the USGS, was subsequently one of my PhD projects. So the incest just goes on and on. It's one big happy family, and we still can never agree with each other. It was also a very salutary project because it had a lot to say. One thing we did learn, well, these guys already had figured it out before the time Comar and I turned up on the project. They'd worked out a very important lesson that we can apply here, and that is that things happen on the coast, events you might say. Some of them are natural, so they have earthquakes too over there. Every 300 years the ground goes down by anything up to 2 metres, and they get a big tsunami, and the last time that happened was about 356 years ago. So they're actually getting a bit worried on the Washington, Oregon coast right about now. They also in 1910 built huge harbour moles, river mouth training walls on the mouth of the Columbia River, sticking out much further than your Hariri harbour moles. And that caused the offshore sandbars, the river mouth bars, to be washed back towards the coast. So this is a thing we call the ebb tide delta, collapsed because the river mouth training walls isolated much of the sandbars, the flanks of the sandbars, from the outgoing tide, which was the thing that held the sand there in opposition to the wave transport, which tried to wash the sand back on shore. So once the sandbar was no longer under the effect of the ebb tide, the sand got washed on shore, and the coast accreted, built out at 5 metres a year for several decades, as it turned out, which looked like manna from heaven to the local real estate agents who duly had it subdivided and sold off, and they built things that they call over there condominiums, blocks of flats. But eventually this sand supply ran out in about 1980. I'm just wondering if this story is starting to sound at all familiar. The sand supply of this collapsing tidal delta ran out. Of course, the sand was being transported towards the coast, building out the coastline on which new real estate was built. But now there was a bulge in the coastline, so the waves generated longshore currents that took the sand away. This whole process took until 1980 to go to the point where erosion had set in. Even though sand had been taken away, there was still enough sand arriving to compensate that. But after 1980, even though some sand was still arriving, sand was now, in net terms, being taken away. And now there were multi-storey apartment blocks built on the shorefront. So the big problem here is that a perturbation, a disturbance had been introduced in 1910, which is when everyone seems to be, because it's quite the fashion to build these harbour mouth training walls. In 1910, the root cause of the problem was created, but the problem wasn't perceived until 1980, when they stumped up, well, it wasn't until the 90s they stumped up $5 million to actually work out why. And they measured everything twice and nearly to death, and this was the major conclusion to come out of it. Well, it turns out that this was a really salutary lesson, because this is exactly what happened here, only here it's even more complicated because other things happened subsequently. But what we do learn from it is that there are these long-term lag effects that ensue, which make it more complicated in terms of working out cause and effect. The other was not really a conflict, but a benefit. I've spent twice now, several days, going along the coast with Jeremy Gibb, who most of you will have met and know. And not only did I get to see this intriguing part of the world, and it's very beautiful as well, but Jeremy is even older than I am, had spent his whole life working on the place. And so he could pretty much tell me everything that had been done in terms of research. And so I had a lot of fun. And if anything, I make this as a declaration because, of course, that degree of exposure to Jeremy means that my ideas necessarily have been influenced somewhat by what Jeremy had to say. And he's not the only one who's worked on the place, and there will be other ideas as well. But given that I'm one of the only 3 people to have read the Clomar report from cover to cover, plus other things that he refers to I've gone away and read, then I've had other inputs as well. So you have to take everything I say today in that context with a grain of salt or otherwise. So going back to this problem of the Environment Court back in 2004, 7 different opinions given by 6 different experts. I mean, part of the problem is we're looking at different time scales, hence my reference to the Columbia River as experts. So, for instance, Paul Comart focuses much more on the coastal processes, and if you've read his report, you'll have seen a lot about coastal processes. So Peter, in fact, that was his gig. He'd drive a jet ski around in the surf zone to measure the topography with an echo sounder and a GPS to work out day to day how the surf zone bars are moving and so on. Whereas George Kaminski, under my guidance, was looking much more at the bigger picture sort of stuff. And this is how come you can get eminent experts who are great mates saying what seems to be completely different things because they're working on different timescales or focusing on different timescales. Then there's also the question of what data or evidence we have to work with. One thing that I benefited from that Paul didn't get a chance to look at is you have this wonderful collection of historical imagery that's now online. It wasn't online when Paul did his work. And Paul based some of his interpretations on reading stuff that was written in the 1890s and then interpreting on the basis of that what must have happened. I had the opportunity to look at the pictures and photographs, that is, and as they say, pictures can say 1,000 words. I mean, it was wonderful opportunity to be able to do that. Wayne Jack sent me the blue things from now on, a bunch of questions he sent me at my request to things to focus on, so my talk's a bit skewed. At the end you can ask your questions, or even in the middle if you like, so that if things that aren't covered by me, at least I say something about, if I know anything about it. Otherwise I'll tell you I don't. I was a bit concerned about this question because it ends up being, they sort of have to bite the bullet right from the outset about ascribing causes to the problems at Westshore. And some of you in this room won't like to hear what I have to say here, and bearing in mind I might be wrong, so take heart. The thing is, overwhelmingly, the root cause of the problem is the beach is too far out to sea at Westshore. And there's been a whole series of events that have made that happen, but that's the problem. It's too far out to sea, and now because of the good town planning that's gone on in Napier, apparently everyone wants to keep it out there. But there is a cost in keeping it out there, that is dollars that go into to managing the coast. The most immediate cause of it being too far out to sea, which is something that's shaped everything about Napier these days, including its fine architecture, is the 1931 uplift. As I say here, it was the second time the ebb delta collapse occurred, and that's the thing I was talking about, you'll recall, in relation to the Columbia River mouth. So it had happened here once before. But what happened was when the coast was uplifted at Westshore and around Napier itself, but around Westshore, it sort of worked a little bit differently from further north up towards Tangoyo, because down at Westshore there was an ebb tide delta of the type I described at the Columbia River, that is, from the tide running in and out at the Hariri. In addition to that, the protection offered by the bluff, it also meant that it was an area, we'd call it a depocentre, an area where deposition was more likely to occur than where the waves were, under natural conditions, bigger and therefore would keep the sediment agitated at greater water depths. So when the uplift occurred, all of a sudden you had either out of the water, as the whole lagoon, the Hariri lagoon, most of it ended up high and dry, and future opportunities for building airports and such things. Even those parts that weren't out of the water were now very shallow. And one thing that happens if you add ocean waves to very shallow water, the ocean waves want to make the water deeper, and they do that because of the asymmetry of the wave orbits, or the water motions generated by the waves. They generally do that by pushing sand in the landward direction, as I described previously about the Columbia River. I mean, there are other great examples of this that Richard knows about, the classic one being, Richard's applied, he's telling me before we started, gave me an update on this talk, in fact, about having applied the Unibest model to getting, which I didn't know had been applied, so I'm glad that's now happened. So this is a model that allows you to examine shoreline behaviour in coastal environments, and it was built by the Dutch Delft Hydraulics Laboratory and Delft University, other people involved in that in Holland. And it was largely developed around the time they wanted to close off the Scheldt River for navigation, but particularly flood. You know, the Dutch have this terrible problem with storm surge and flooding. And the Scheldt River is a huge estuary, in point of fact, with a mesotidal range, so it had big tidal flows hooting in and out, and the outflowing tidal range was creating this huge ebb tide delta. So when they built a dike across the front of it with a little, sluice gate to let the ships in and out, they turned off the tide, but the waves in the North Sea were still there. So exactly as I've described, that's what happened there as well. The ebb tide delta started migrating onshore, driven by the waves, and caused the coast to build out. Before that happened even, because the sand lobe is moving towards the coast, and of course the water gets shallower. You're trying to put a body of sand into a smaller volume of water. Next thing we know, we've got islands appearing, brand new islands appearing in front of the old Skelt entrance. And this process took quite a while to occur, so the islands became vegetated, became bird sanctuaries, and next thing you know, the Dutch population are screaming like crazy that these islands have to be preserved at all costs because they're valuable, soon to go extinct migratory bird sanctuaries. But of course, it's too late. This process has been set into train, and other than building more dikes to stop it, eventually the islands get to the coast and make a very wide beach, and then the sand starts being redistributed along shore. So, this is not an unusual phenomenon. It happens. The first time this process happened here was with the construction of the Hariri training walls in the late 19th century. And so just like with the effects of the earthquake, but on this occasion, not because it had got too shallow, but just like on the Columbia River, the walls had isolated the flanks of the river mouth bar, or the ebb tide delta, from the tidal jet, which was now constrained between the walls, and there was rapid accretion at the shoreline, particularly on the east side, but also on the west side. And the accretion was so quick, so spectacular that here, just like it happened in Washington State, the local real estate agents rushed out and lobbied their councillors to subdivide the land. And I couldn't believe it. I mean, the maps are all available on the library site. Within 10 years, the land had been subdivided. Some of it's been inhabited, some of it's been reclaimed by the sea. One of the funny things that happened was, of course, everyone's heard of the old freezer works. They were built on this brand new land, as Paul Comar points out. It wasn't there 10 years earlier, and hey, there it is. So they built the freezer works there. And the timescale was much more sped up here because this isn't as big as the Columbia River, it's quite small, but it was still a sort of multi-decadal process. So by the time they built the freezer works, erosion had started to ensue where the coast was retreating again as the sand got reworked along shore to the north because it was too far out to sea, as it is now. And the really funny thing is they finally gave up on the freezer works. I think it was about the year before, or 2 years before the earthquake. So if they'd hung out a bit longer, it would have been all okay. The good Lord would have intervened once again and bang, preserved not only the freezer works, but the land on which quite a few people enjoy a very nice coastal lifestyle these days. So they're the main game. Well, in fact, I only include the Hariri walls here as a legacy because the process worked its way through, was coming to a completion, just as I mentioned, hadn't finally completed because the land wasn't gone before they pulled down the freezer works, but was getting there by the 30s. By now, it certainly would have been worked through to completion, would have nothing to do with anything. So the main legacy here is it created the subdivision at Westshore that is now the thing that needs to be preserved. Well, some people think it needs to be preserved. It'd be easier if it wasn't there, but... So the second thing, which is a real paradox, the second cause, is the beach nourishment program. Now, it's maybe less serious because it's self-correcting. You just add more gravel, and of course, the erosion effect is somehow remediated, at least for a while. But you have to keep that process going. But why it is a root cause is the beach nourishment program maintains the beach way seaward of where it wants to be under natural conditions, and, more to the point, where it was previously when conditions were in fact natural. So you can't rule out this, and they are the two most important today, in 2017, they are the most important factors in this. Here I get a bit more controversial because Paul Comar's went to great pains to say that, well, there was no sediment interruption, and due to the construction of the breakwater, it didn't really discuss the dredge channels. But I, having had some concerns about what I was reading in terms of things not stacking up, reanalyzed the data, and I have to say that I don't agree. So we're already, if somebody else has got expertise here and wants to put in a third opinion, or even not, you know, we only need 2 experts to have 3 different opinions, as we found out in the past. But anyway, so already we've come off the rails. 2 eminent scientists, well, I hope there's 2 eminent scientists, have come up with completely different views on this topic. Anyway, I'll say a bit more about that, but so my view is that there was a gravel supply. I agree with Comar that it wasn't a huge gravel supply, but it was significant and significant enough, and other researchers who have modelled things and done investigations that Comar review also say this, that it was significant enough to now create, and post-port construction, create a sediment budget imbalance. And I'll say a bit more about what the sediment budget involves in relation to long-shore transport in a little while, but it was significant enough to interrupt the gravel. Anyway, so Comar said it didn't interrupt the gravel wasn't getting around there anyway. What the studies Comar reviewed all said, and Comar agreed with in his review, that it did interrupt the sand supply, or at least it deflected it or somehow disturbed it. So this is the sand supply from where? This is the sand supply from where we are here, being driven to the north and around the bluff, and these days around the port, into Westshore and the coastal cell north of the bluff. In respect of both these things, both the gravel and the sand transport, I should point out some of the sand gets transported in the beach because the beach has got a whole mixture of grain sizes, but most of it is actually out in the surf zone or immediately offshore. And there's very little gravel out there. It's mostly sandy, and there's, as we can see out the window, rather compelling waves to transport this stuff. So most of it transports out there. And for that reason, as Comar rightly points out, there's much greater capacity for the sand to bypass around in deeper water, bypass around the bluff and the port in deeper water. And as I understand it, contention has now also arisen, not just about the gravel, but also about the sand. Well, this deficit in the wave-driven longshore transport, what this means is there's a gradient, a positive gradient in the transport rate. That is, on the downdrift end, so that's further north, there is faster transport than in the updrift end, that's this end, so the input is now less than the output. So that increase in transport rates moving along the coast is a positive gradient. I probably just made things more difficult by saying that, but I really feel obliged to emphasise it because in a lot of coastal process reports and studies you see, people just talk about the transport per se. The transport doesn't matter. What matters in terms of geomorphic change, that is whether the coast is building out or whether it's retreating, is not the amount of transport, it's the differences through space. That is the gradient in the transport. If you can have a lot of, like Fraser Island, you might have heard of Fraser Island, I think it's about as big as New Zealand, isn't it, North Island? It's bigger, the world's biggest sand island. 45 kilometres of that is dead straight, ruler straight, and yet it's just a big pile of wet sand. And you have these southeast waves, and sometimes from the northeast with cyclones and so on, that happens as well, hooting along the coast, driving sand at maybe 1 million cubic metres a year, but because the sand is being driven northwards along Fraser Island, then it falls off the edge of the continental shelf, but until it gets to the end of the Fraser Island, it's 1 million cubic metres everywhere. Zero transport gradient, there is no coastal erosion, except for short-term stuff related to storms, and it's just a sort of a fluctuation, but there's no systematic change. So the gradients are very important to look at rather than the gross transport rates. One problem immediately arises from this is in our sediment transport theories is we have to ask how accurate are they? So the answer is they're not very accurate. So Richard's applied the Unibest model. It has to make some sort of assumptions about sediment transport. It's a big, big challenge because in the end, well, we don't even get into order of magnitude accuracy about the gross rate of transport. So if we're looking at under a wave, what is the amount of sand that gets moved shoreward when the wave crest's going past and then gets moved backwards when we're in the trough phase of the wave. We're only less than order of magnitude accurate with that figure, but what we really need to know is what happens after gazillions of waves have gone through. Now, this is many waves every day, every month, every year, and so on. What we need to know is how much got moved shoreward, how much got moved landward, and then what was left. So it's the residual. So the residuals are probably less than 1% of the gross transport rates. We got no way of ever knowing this, probably. Well, we certainly don't have any way of knowing it now from empirical and mathematical theory for sediment transport. It's a major problem, and one of the reasons why we can come up with such different opinions, because in the end, the opinions are really what we have rather than some sort of definitive answer. Question one's the biggest question, so that it continues on for more than one slide. In fact, it continues on for more than 2 slides. As Komar points out, the port did one really good thing for Westshore, is it created a zone of sheltering. And this not only affects the transport rates, so if you apply sediment transport modelling as clunky as it is, before and after the port, you get so nature and post-port different answers anyway, but it's pretty easy to see that the port built the breakwater to shelter the shipping, but it also shelters Westshore from erosion events. That's what it affects shelters it from. Maybe not if the waves are coming out of the north, or the northeast, associated with passage of tropical cyclones, although they're usually not tropical cyclones by the time they get over here, are they? But they can be still pretty nasty weather events with northerly waves. Don't provide a lot of sheltering from that, but by and large, they are only rare, very rare events, and the ones that occur mostly, it's a better part of the coast. So it plays a role there, but that's on the plus side of the equation. Thank goodness the port's there when we have big wave events and everything starts to be overtopped. So you see I've got a question mark here. Richard, you see I referred to Unibest, so despite the disparaging words I said about sediment transport theory, I mean, we have to apply all the tools that we have, and that's one of the best. So it's now been done, and I look forward to having a look at those results. Well, Richard, I should ask, so first question to ask, I'll ask it. I read something where, was it Shaw Mead, or somebody had done some altered wave refraction patterns.
So I think just with regard to Unibest, I did from take care that was the port, so not round the port.
Right. Okay, so the question mark's still there. Somebody should pay Richard to do a bit more work and go north of the port, because whilst I say the shoreline is too far, the beach is too far out to sea, for the reasons I've explained, there also will be an effect on shoreline configuration, potential effect on shoreline configuration, that the existence of the port, because of wave refraction and diffraction, this is the bending of the waves as they come around from basically the southeast around to Westshore, that refraction pattern will have associated with it theoretically a shoreline curvature or configuration that will be on a time average basis over decades stable. But we don't really know or have any idea what that might be. Well, you do?
So the addendum to that is, you're quite right, Shaw Mead through ASR did some wave fraction and some quite rudimentary US Army Corps of Engineers certain climate transport estimates. And then Woody Parsons have done some work decade ago on shoreline evolution
Well,
and the ports.
I've got that somewhere. It's a thumbnail dipped in tar type of thing, though. But that was, Sue type model, yeah. Okay. Anyway, so we don't know about that, and it'll have some effect, but it'll be overwhelmed by the effects that I've already been discussing. So the earthquake still is so in your face. The earthquake effects and the nourishment effects just overwhelm everything in terms of where the shoreline would want to be. But it'd be nice to know, because one of the things I would propose is that if you have to work so hard at keeping the beach where it is, why not be a bit easier on yourself and let it be closer to where it wants to be? I say closer because where it wants to be really might be way further landward than you decide that it's permitted. Larry might have a lot to say about this because his house could be in that particular area. However, I suspect it wouldn't be. So re-evaluating where the coast, the beach should be is something that I would say is a priority piece of work, and one of the first things you would do in that regard is apply Unibest or Mike 21 or one of these highly tricked up coastal area models. Sure.
So what you haven't talked about is the possible dismantling of the wall, which you see as the primary cause.
No, I wouldn't. But we have to talk about, I've been talking about causes, but I haven't been talking about solutions. And clearly, that's not a solution. I don't think there would be anybody in Napier who would say dismantle the wall. The whole raison d'etre of Napier is behind that wall. I mean, it is the economy. So that's not, or what do you think? I'm only saying that as a visitor. So I'm not proposing dismantling the wall. What I am proposing is recognising causes and effects and then finding a solution once those causes are recognised. So here I differ from Paul Comar in that he was saying it doesn't cut off the gravel supply. I say it does. And in saying that, I would say, well, therefore, we need to take that into account in finding a solution. But I would never say that all the white fellas should move back to, that northwest, those little islands off the northwest coast of Asia where they came from. That's not going to happen. So I won't say that. Okay, storm erosion. I've already covered this. Paul Comar said it wasn't, he had two things to say about this. He said that the coastal erosion that appeared to be the case, appeared to be occurring, was due to storm erosion. And, but he also said the breakwater protected Westshore from even more storm erosion. Well, he did this by looking at some tables of beach change numbers, I think that Smith had prepared, and something worried me about it, so I actually went back and analysed the data to see how important storm erosion was, and I'll show you those numbers in a minute. But the upshot was, you do not have a problem with storm erosion. If you're there in 1974 and the sea's got so high that it's pouring over the top of the ridge and so on, you might think there's a problem with storms. And if you go there today, you see the top of the Nourishment, the artificial ridge, is chopped out and so on. So it looks sort of ugly, depending on your view of the world. I quite like it myself, but Larry doesn't like it, he hates it. But I would say, regardless of what you think about it, it is primarily an aesthetic problem. So I don't think storm erosion is an issue, and I don't think the data indicate it in the end either, after a more careful analysis. One of the things that was thrown up in the Comar report that also, in the context of the things like the Columbia River mouth and so on, made me think again was, coastal erosion at Westshore is nothing new. As soon as people turned up and started building things on what was a sand spit, they built these things on a beach. The hubris of the Scots and the English when they did that is unimaginable. Anyway, there was a buck to be made, I suppose, and pretty soon on, one of the legacies we still have is all this stuff's there. These attempts at protecting the coast, nothing new, it's still all there, and it doesn't do much for the aesthetics unless you're an archaeologist and you can go down there and see what our previous generations, our ancestors were doing. Not the Maori, of course, they were much more sensible than to put concrete blocks on the beach. Surfers don't like concrete blocks, and if you're running a council, you should be aware of this, because one of the most frequent sources of liability, if you build a seawall of any description, is people, citizens, injuring themselves, which includes spinal fractures, very common. One of my colleagues, Andy Short, I think he bought his second house based on being in court over spinal injuries because people did this. So Wayne, bear that in mind. I think the buck will stop with you. So lots of detritus. When I looked into it a bit further, these are spits on a tidal inlet. If we know anything about tidal inlets, they're as mad as cut snakes. Under natural conditions, they move around all the time. The shoreline is why building a house on tidal inlet deposits, like these spits, is just nuts. Okay, they didn't know any better, and they were there on a good day when they put the house up, obviously, but they move a lot. They move on an 18.6-year cycle. This is the cycle that the tides follow. The Dutch Barrier Islands change in volume by 1% just due to this 18.6-year tidal variation. Well, at least when there was water in the estuary, that would have been going on here as well. But in addition to that, you have fluctuations in the sediment supply. So if you believe, as I do, it was going north around the Bluff. The sediment supply is related to river floods, which once every blue moon jet a whole bunch of gravel and sand out onto the beach and then do nothing for decades. And as Richard Ryan Hamill has done, has analysed the volumes of material given up by rock falls off the cliffs. There are some big cliffs, particularly kidnappers. They don't happen every day of the week either, so you might have to wait decades to get a good one that then gets reworked into the transport system. So that's going to show up eventually down here, down at the other end, at Hariri, as a slug of sand and gravel coming through, and of course that is another source of instability in the whole thing. I haven't put a number on this, I've put an N on it because, well, it's sort of out of our real frame of reference at this point, except that Paul Comar thought it was important enough to point out the previous studies that had been done as beginning of the 20th century, mid-20th century, pointed out there was coastal erosion going on at Westshore way before there were even the harbour moles. And it's perfectly true. But one of the first things I did when I started looking at this was reading everything and writing it down in chronological order, summarising it in chronological order, so I could see which cause and effect came first and then ensued. And so one of the things that happened before, because Paul had already pointed out, well, this guy said that there was erosion before they built the harbour moles. Well, what was going on before that? Well, some bright spark, one of the early entrepreneurs, they really wanted to be a harbour badly, so they started dredging this shallow estuary. And one thing I will say right now that needs to be taken into account right now is that the two most common causes of coastal management problems in the Western world, and this is part of the Western world, even though it's a long way east by most measures, is first one is these harbour mouth walls, so these training walls, and sea walls to that effect. The English are now pulling out their sea walls. They're losing 10th century monasteries and all sorts of archaeologically significant stuff because they think it was such a problem putting in these walls that they see the only way forward is to get rid of them. I'm not sure that's a good idea, but that's what they're doing anyway, so that's their call. And the second big problem so there's some recognition now of hard structures and what a cock-up that turns out to be in many cases. Not all. You can use them in the right place, but in the past, they have been a serious problem. And I think the chief scientists of the UK estimated they were spending $1 billion a year out of their budget on, this is now a decade ago, on managing these cockups. So, and they've been occurring over centuries, so it's an accumulative effect. So that's, I think that the financial imperative was why they started pulling them out. The second thing, which goes almost unreported, but is a huge problem, is dredging harbours. So your first coastal erosion problem at Westshore probably was associated with this minor dredging works in this little tidal inlet to get in bigger vessels, which was a pretty important thing to do back then. Because what happened, the reason you need to dig a hole is because there's too much dirt there. And how did the dirt get there? Well, of course, nature put it there. And so if you dig the hole, what is going to happen, quite understandably, and Richard and I even have models that show that this will happen, is the hole fills in again. So it's not the case that you don't have navigation channels. We need navigation channels. But like other coastal management issues, they need to be managed, and that means we need to engage in recurrent dredging. We have a great story in southeastern Australia. We have a thing called the Tweed River, which is the border between New South Wales and Queensland. I assume you've heard of New South Wales and Queensland. I mean, they're important to us anyway. So what happened was, in 1910, just like on the Columbia River mouth, the local trawler operators lobbied the government in New South Wales to build river mouth walls, just like the ones at Hariri and Columbia. And as soon as they did that, they cut off the 500,000 cubic metres of sand going from New South Wales to Queensland every year, and caused a major erosion problem on the Gold Coast. Except that the Gold Coast wasn't there, well, the beach was there, but no one lived there at that time, so they didn't really care. They just let it erode away. But eventually the sand built out on the south side so far that it started out flanking the training wall. They did that quite quickly. And now the trawler operators there was a major port back in those days. No one was happy about that, so what did we do? We extend the wall. Well, that happened in the mid to late 1960s. But now there were people living on the Gold Coast, but we hadn't learnt anymore, despite having already run the experiment once. The sand was cut off, so there was now 500,000 cubic metres going north out of the Gold Coast beaches, and 500,000 cubic metres no longer coming in from the south. And so the Gold Coast beaches now eroded way back to the condominiums, and this precipitated a lot of angst, including Queensland wanting, you don't have states, so count your blessings. You could have been part of Australia at one stage, and there were these different countries. It was much more likely that New Zealand was going to sign up to the Federation than Western Australia, and they're still wondering if they did the right thing. But anyway, so these different, like African colonies, Queensland wanted to sue New South Wales for causing all this damage. New South Wales, without any shadow of doubt, wrought destruction on the tourist industry in the coast of Queensland. Not to be outdone, Matthew Lawson knows how this works. New South Wales countersued Queensland for taking New South Wales sand without paying for it. No, I kid you not. I mean, lawyers. If you work with lawyers, you know how they work. So this actually happened. And eventually the governments worked out, this is crazy, so let's get together and do something about it. Let's solve the problem. We want to have navigation, we want to have beaches, we want everybody to be happy. The Aborigines were already happy because it had created all this extra land that they immediately put, well, when we eventually got around to recognise that they existed, in the late 20th century, they put a land claim on it. So it was interesting that they put a land claim on something that wasn't, because they had sort of heritage connection with the land that didn't exist before they built this wall, but they always succeeded. And so that was really good. So that was the one big positive to come out of it. And the next big positive, the antagonists in this story decided they'd work together. They'd work on the same page. And what they came up with was the Santa Barbara solution. This is Santa Barbara Harbour in the USA, the beached river of sand. Some of you might have heard about famous Scripps Institute of Oceanography educational film on that. Still a beautiful film. What happens on the Californian coast, all this sand comes down out of those high mountains that they have, just like you do, for the same reason. You know, you have the tectonic collision zone, and it snows up there, generates a lot of water and sediment transport, comes down the coast, gets to the beach, turns left, and heads, I always get my northern hemisphere stuff mixed up. Anyway, heads along the coast as a longshore transport until it goes down a canyon. And if it comes across some place that people want to run a maritime business, it's a problem. Because if you have a harbour, it just fills up with sand, and well, not entirely, but enough to make navigation difficult. So what they decided to do at Santa Barbara, the Americans are good at inventing new technology, was they pumped the sand, they built a barrier, intercepted the sand, put in a huge pump, and pumped the sand across through pipes underwater to the other side of the harbour. So the sand never got into the harbour or into the harbour mouth. Worked a treat. Well, that's what we decided to do decades later when we figured out in Australia that there were other places in the world that they might have had similar experiences, and maybe we should draw from that. The Queenslanders and the New South Welsh men put in a sand pump that pumps the sand across to the other side of the Tweed River. We can now navigate the Tweed River bars because the bar's no longer there because the sand source for the bar's taken away. And now the problem in Queensland is not that they have coastal erosion because of the New South Wales stopping the sand. The problem is they're being sued by the tourist operators because the beaches are so wide that the tourists burn their feet when they're walking across the beach in summer. The surfers are very happy, however, and I know you have a nice surf break here, because they have a thing called Superbank. It is one of the truly wondrous things on the planet today. This amazing surfing bank, and you've probably seen it, pictures of it in the paper or on the internet. The only problem with it is everybody comes from every corner of the planet and wants to surf it. So, you know, you barely can see the water underneath the surface. They're so dense. But it is truly a magnificent surfing break, and we get it from pumping this sand past, as it turns out, faster than nature actually did it, which wasn't so good for the Aboriginal community because the land that they could claim, because it was being pumped away so fast, started to disappear. So they're back in court over that one. Anyway, so these things can be managed. I can't even remember how I got onto that, but never mind. So this is one of my reanalyses of the data that Comar referred to think that storms might be an issue. So the maximum, and these aren't even necessarily storms, because what are these? There's survey data out there, but you know, back in the beginning of the 20th century, they didn't do them too often, so you've got long periods of time between successive surveys. So all I've got to go with is change between successive surveys, changes in volume and position of the beach, which is what Comar looked at. He looked at the tables and said, well, this and that's happening. Well, I plotted it up, and it ain't happening. So it's one of those things, a bit of extra analysis, and you get things out of it that you mightn't have seen in the first place. So in terms of volumes, at Westshore, even with, 10 years between surveys, it's still only, well, there might have been bigger fluctuations in between, but the biggest thing we've got is a change in around 40 cubic metres. And I can tell you from open ocean beaches, this is a trivial change. In terms of shoreline movements, and again, the biggest shoreline movement of 15 metres in both cases, we manage our open ocean beaches for a 100-metre shoreline change. And we know you had the 1974 storms being a pretty big event in Napier. We had them as well, and we got 100 metres of shoreline change for that shoreline event. So that we factor that into our hazard lines and so on. So Westshore, it's trivial. This has got long gaps between most surveys, and you see that if you close up the gaps rather than getting bigger fluctuations, you get smaller fluctuations. When we get up here, we get to the HB survey data, and the fluctuations get even tinier. I mean, they're less than 10 metres shoreline excursion. So this is the movement of the high water mark, and backwards and forwards with erosion due to storms and then recovery in the fair weather period. So and I won't go through the details, but these grey things are the storms reported in the couple of studies that report on when the big storms happened. That's when they happened. And, well, you can see here, there's obviously a bit of erosion associated with this one. It's only 10 metres of shoreline movement. That might be about 1974, so it did have some effect. But, you know, in terms of volume, what it means is the shape of the beach changed, and a lot of the gravel went from the upper part of the beach down to the beach step, which we know that's how gravel beaches respond. Hasn't been actually lost from the beach, but it's lost out of the survey zone, if you like. So we still pick it up, so the shoreline movement looks bigger than in the volume. Okay. So next question. This is only question 2. How many questions were there? I think there were 10. I was wondering if that was deliberate. What role did the earthquake play? Well, we can now gain efficiencies from all my blathering on, because I've said a lot about what the earthquake did. A lot it did. The beach is in the wrong place. I also explained why the effect was bigger at Westshore, that is in the vicinity of the Hariri estuary, because the Hariri estuary was there and had created a sand deposit offshore, being the ebb tide delta, the sandbars associated with the tidal flows. And so that shallow water provided a sand source that, once things had got even shallower, meant that the forces driving sand on shore were much bigger than anywhere else along this stretch of coast, and created a bulge in Westshore, just like this is an outward bulge in the shoreline and beach, just like the bulge I described on the Columbia River that George Kaminsky and others spent $5 million looking at. What's happened now, of course, is that we've run out of the sand that was coming off the ebb tide delta, because it's all come off, and now it's being redistributed away, except of the management intervention that's stopped it. And as I've already mentioned, this was the second collapse of the ebb tide delta, the first being due to the Columbia River type training wall phenomenon. There's also a legacy effect that is entirely attributable to the way you're managing it here, is that the nourishment fill has been placed along Westshore in a ridge way too far seaward of where the coast wants to be. And it's a high ridge. And what happens is a beach, well, engineers call beaches wave absorbers, and they put them in their wave tanks, precisely that, to absorb the waves so they don't get extraneous reflections and other things that they don't want to have. And the idea is, if you have waves coming in and they get absorbed by the beach, the transport is dominantly in the shoreward direction, so they deliver up material to the beach, and the beach builds out. Whether the beach builds out or not is simply a function of whether the wave run-up is stronger than the backwash. So if you build a big ridge, that particularly during storms, you have the waves crashing into this ridge, and those of you who've been there have probably seen quite strong reflections, not just backwash, but reflections of the waves that run back down the beach, and you can actually see them propagating back out to sea a short distance. And what that tells you is that you've shifted the bias between onshore transport in the wave run-up and offshore transport in the wave run-up. So despite the fact there isn't significant beach erosion, you certainly haven't done anything to encourage sediment to be on the beach by having such a steep structure there. So it would be much nicer if the structure was modified in some way to reduce that effect. So this is the diagram that Richard referred to previously. It was prepared by Worley. I haven't seen the study, but it was in this Becker report that I read, and it's a thumbnail dipped in blood by the look of it. But to use that expression, thumbnail dipped in tar. It's based on a very parametric shoreline modelling technique that is, as it turns out, it's very crude, but it's as good as any in many respects, simply because of the uncertainties we get in modelling shorelines. But what is indicative, so this ain't gospel by any means, but it's still indicative. And if I was going to put into a picture what I've just said in words, which is based on concepts and qualitative reasoning, if I was to draw a picture, it would look a lot like this one. And you see the red curve is where wall is reckoned based on their rudimentary analysis the shoreline wanted to be, and it is actually at Westshore significantly landward of where the beach actually is. In this vicinity, I think their model's just not working. It just doesn't apply. So it's kind of different right in the lee of the walls and so on. But nevertheless, all through Westshore, it's landward of the present beach line. I think that's a fair statement of the major problem. The beach is simply too far out to sea. Out to sea. It's an expression for things going wrong. There's also a bulge up here. I don't know. I don't even know when this map was compiled, but suspiciously around, certainly after the time that Nourishment began, and Jeremy Gibbs tells me that a lot of the Nourishment material simply goes north, and is actually, he I think alerted me, or was of the opinion that this bulge here was actually due to longshore feeding from the Nourishment material. And if it was after the time that dump zone R, or whatever it was called, when dredge spoil from the shipping channels was dumped around the esplanade, it may have had a contributing factor as well. Pure speculation, but yeah.
The beach profiles are free to get those.
Yes, and it looks, you know, we wouldn't be here today if Westshore looked like those locations. I mean, it looks, you know, well, it's not made of sand, Larry, but it's the aesthetics I can see might be regarded as superior. Did I answer all that question? What effects, short, long term? Yeah. So there's an effect lingering from the earthquake, and it would have been starting to get towards the end of things well and truly by now, had it not been for the beach nourishment. So, it's by no mistake, this cause and effect. That's why you put things into chronological order, because it turns out there's many problems in life, but coastal management, certainly one of them. Something happens, we do something to it, like we build a harbour entrance, other things happen, so we do something else to fix those other things. That causes an additional effect, and this knock-on effect goes through time over and over again. And it's great for business if you're a coastal manager. And you can feel quite pure at heart about it if you don't actually know what's going on. Anyway, so the knock-on effects have all now gone, except for the legacy effect of building those river inlet moles on the Hariri that led to the subdivision of land that's now being protected. So that's the main legacy effect, is the protection, and that's what's now maintaining the coastline too far out to sea. What happens to the report breakwater training? Well, as I've already talked about this as well, so this also goes into there's a future proposal in train to enlarge the port, which has only got to be a good thing for the economic and social future for Napier. But I say, based on my interpretation of the data that Comar reviewed and studies that Comar reviewed, is there has been an interruption of the sediment supply, both the gravel and sand component, by both of those walls. Who cares about the Hariri walls anymore? You can't take away the cadaster. It's now there fixed by the stars, which is how you map cadaster. So unless you take away the stars or do some serious town planning, it's there for good. And the shipping channels have also had some some role to play here. Now, I understand there's a report, forthcoming report, that some of you have seen, but others haven't, including me, that goes to what the proposed shipping channel, I suppose, because the experiment's already been run, what the existing shipping channel has done, to the sand budget. And I believe that this report involves a counterclockwise gyre that seems to take the sand off Westshore Beach or somewhere else inshore out into the shipping channels, and therefore might be a problem. It's pretty common for concept models, often based on actual modelling, to come up with these sediment transport trajectories. And that's a right and proper thing to do if we're trying to come to an understanding of things. However, there's one thing that needs to be understood well and truly here. And it's an idea that was actually Marcel Stever's terminology, an idea developed at Delft University, and we wrote the paper about it together. I think it was published in 2003, but it's been republished in various forms by various people ever since then. Marcel's idea is that in the end, it's so complex. The sediment transport in nature is so complex because the tide phase is changing on an hourly basis. The waves are different, not just every other day, but even on any given. If you talk to a surfer, they're always saying, "Oh, you should have been here an hour ago." They changed that much. My PhD supervisor who moved to Virginia Institute of Marine Science to run it. He used to put out current meters on the east coast of the United States in a shelf. And I remember making the mistake once I got into the business of trying to scale up sediment transport relations and whatever we know about sediment transport. And I was working with him at that time over on the part of the coast that the Wright brothers flew their first plane, everybody's first plane flight on in North Carolina. And so I said, I don't want all the numbers, Don. I want to know, in net terms, what transport's going on so I can stick it into my model. And so he sent me off to one of his proteges, Carl Friedrichs, who gave me a stack of CDs and said, "Here's all the data." And that was a big statement because it was saying we've measured it all in more detail than anybody in the history of the human race, and we can give you the data. In other words, they didn't know what was going on. When he eventually wrote this up, I remember there was one statement that I always use when I publish this sort of stuff these days, and that is, he said that far from knowing what the rates of sediment transport were or what happened in a single storm event, which in the scale of managing a coast like this, we were interested in all the storm events that happen over year after year, but just during one storm event, he reckoned his measurements of sediment transport changed dramatically just in the course of that single event. So he couldn't tell me during one event which way the sand was going in net terms, much less what happened after maybe 100 such events, the things that might shape the coast. And so, we used to think we knew a lot more than we actually do now, and certainly that happened in the 1990s. He put out those current meters. In the Perfect Storm, you might have seen the movie or read the book, so he did it in that. He didn't put them out during that, but he managed to record it all. So Marcel, being cognizant of this, came up with this idea of the sediment sharing system. And in many ways it connects up with the geologists, which is more what I do, and the way they think, sort of big picture. Because of the variability in the forcing, that is in the waves and currents over there, because it's weather after all. You tell me how to characterise the weather, I'll give you the Nobel Prize. I mean, it's an extremely hard thing to do, is to characterise the ocean weather, and it changes so much. And then we have these uncertainties about sediment transport, which are 1 to 2 orders of magnitude in terms of our ability to be accurate with it, which we have to stick into our models, along with this ocean weather, to work out where the sediments are going. So the idea that Marcel came up with is that these sorts of environments are simply sediment sharing systems. What we do know is the stuff is moving all the time. And that was the one thing that Don Wright was able to measure, able to measure how much stuff was in motion from second to second. And that's a lot, particularly during the perfect storm. So this stuff is moving around. And the best way of thinking about it is like there's a big washing machine out there. And the washing machine has an agitator, and the agitator gets more intense the closer to the beach you get. But it agitates out into quite deep water, 40 metres, on a coast like this, easily into 40 metres of water. We know that after that, maybe not so, because we start to get into muddy sediments, which wouldn't be there if the agitation was as intense. Anyway, so there's this stuff's just going everywhere all the time, and we want to know where it's going, right? Well, the best thing then to do, to find out where it's going, is to look at the deposit. So you look at where it's eroding and where it's depositing. You can actually measure. These days we've got this fantastic stuff like LiDAR, and we'll even use LiDAR offshore now in aeroplanes. We can survey the seabed flying across in an aeroplane. Go figure. Don't know if it's right, but they do it, and they give us the data and they say it's right. So we can actually measure the terrain out there. We can work out how thick it is from seismic surveys, and onshore from ground penetrating radar. It's another sort of seismic survey. And so we know, and we can even get dates on this stuff so we can know about accumulation rates. And what it tells us is that if there is a place that the sediment is accumulating, we can see that that's a sink. And if you know you're going to dig a hole, well, that's going to be a sink. On the other side of the equation, there are places that are eroding in net terms over time, and the stuff's got to come from somewhere, and that's a source. So for those in the port business, and we must have ports, it's just like beach nourishment. It's an ongoing investment you make in having the port operate, because regardless of where you might think most of the sediment's going to come from, if you've made a sink, it's going to come. And it's going to fill in the hole that you've dug, which you will maintain by dredging. And because in our economy people want that navigation to persist, then resources are allocated to do it. So that's the answer to that question. What do I think about that? How come it's question 3? I did this at 4 o'clock this morning. Oh, it is only question 3, right, okay. What influence does the wave angle have on all of this? Well, it's easy working here because it's just like Southeast Australia. It faces the same sort of climate. Our predominant wave energy comes out of the southeast quadrant, and it arrives after being bent by headlands and shallow water at the coast, still at an angle in many places, unless the headlands are really prominent. Cape Kidnappers is pretty prominent, but around Sydney, the waves get so bent that they don't actually produce any alongshore transport or alongshore currents in net terms. Here, the headlands are further apart, and even though this Hawke Bay is a big indentation, we still get a wave angle at the coast. Paul Comar, in his report, included many fine diagrams from his long and distinguished career, but he didn't include this one, which I think is the best thing he's ever come up with, really, in 1973. So long ago, he probably can't remember it. And I'm a bit younger, so even though he did it, I can remember it. It impressed me greatly at the time. Pretty much summarises what's happening here. If you get a wave crest, shown here in this line, arriving at the coast, forming an angle with the coast, then if you like, the water gets squirted away from the parts of the coast that are closest to the wave crest. So here's the Tweed River. Well, okay, the Tweed, if you look at it, doesn't stick out so far, but the delta geologists will tell you in a high wave energy environment, and that's what this diagram also from Comar down here says, the higher the wave energy, the faster the sand, so the sediments, gravel and sand on this coast, are being discharged at the river mouth at a certain rate. And then they're transported away from the river mouth at a certain rate. So the bigger the waves for a given discharge of material at the river mouth, the bigger the waves, the faster the sediments are transported away. So on some high-energy deltaic coasts, you don't see a bulge like this at all because they're transported. You don't see it, but it's there. It's very subtle. But the size of the waves mean it still makes the sand and gravel get transported away as fast as it arrives, or almost. So there are two things going on. Wave, bigger, you know, if you've gone swimming when the waves are big, you know you get worked over much more than if you go when it's small, so they can do more work under those conditions. The other thing is you'll notice there's this angle between the beach and the wave crest. So the optimum transport rate for any wave height is when that angle's 45 degrees. So if you reduce the angle of that the delta makes with the coast, or the waves make at a coast, when it becomes parallel to the delta, the alongshore transport, parallel to the wave crest, the alongshore transport goes to zero. And so the fact that the waves are so big here, you don't need much of a bulge in order to get this process happening. Plus, probably the waves are still, because they're coming from down there, heading in that direction, roughly speaking, there's still a bit of alongshore obliquity in the wave crests anyway. And in many respects, what we see here, and what the interesting thing about this diagram is it's quite an unusual one when it comes to alongshore transport representations, even though it's back in 1973, probably one of the first ones. Comar lives in Oregon. Oregon is like New South Wales, it's got headlands. And so Comar thought, I'll put in headlands. And that's just like here, we've got Tangoyo down the other end, and the only thing that's missing in the middle is the bluff. But nevertheless, the whole thing characterises what's going on here. So if we have a look at the effects of the alongshore transport, the rivers are down here, near where we are. We're here, the rivers are down here. The important one being the Tuki. And before there was any port or anything of that nature, my contention, contrary to Paul's, is the gravel and sand was going around the bluff. So this was some minor obstruction, relatively minor obstruction in the previous diagram that's not shown in the previous diagram. Here it is zoomed in a bit more from this old historical map. It's called Eastern Spit, and it's just classically what you see when you look at a headland attached spit. I mean, you can't build spits in reverse, so it goes from the supply end, and you even have a series of recurves, minor geomorphic details that actually tell you about how the thing's grown along, that says, irregularities in the lagoon side of things, going along this shoreline, and with deposition and bypassing at the end of the spit. It's even a so-called, has a drumstick configuration that Skip Davies, Richard's the only one I've ever heard of, R.A. Davies, describes in relation to barrier islands that on the downdrift side of an inlet you have a bulge in the end of the barrier island, and the updrift side it's quite narrow. It's exactly what we've got there. But the real clinchers are if you go and look at the old photos. There are photos of this before the port was there and so on, and that was what wasn't available to Comar at the time. He did have this diagram that once again, so now that's south up there, so the sediments are coming around. They've even got depth soundings here. It's all quite shallow offshore, shallow enough certainly for sand transport, and certainly shallow enough for gravel to be rapidly bypassed because of the extreme exposure of the headland and the roughness of the cliff face, bypassed around the corner, building the spit out in this direction from here. Here are these recurves that I was talking about before, multiple recurves. So this hook here and this hook here were created when the inlet was further along. Often what happens with these things is they get breached, and then you get the whole reconstruction of these spits occurring over again, sort of migrating inlets. So what's the implication of this? This is sort of cutting to the chase about the so whats in terms of alongshore transport and what causes it. Well, this is a photo. This is the courthouse. This is the court. breakwater. And you can see there's the bluff, and you can just make out the shoreline is pretty well intersecting the end of the bluff. So the analogy I would make here is that in that diagram of Comar's, the bluff is like a weir, and upstream of the weir you have this reservoir of sediments, a sink in fact, a reservoir of sediments. And just like with a weir, if you increase the height of the weir, you increase the volume of the reservoir. So by building the port, that's in fact what was shown. This diagram is actually from a publication that Paul put out from working here after he did his 2004 report, and showing this part of the wall here and drawing a shoreline well proud of the bluff, as we can actually see if we can contrast pre-port construction and post-port construction. Looking in the other direction, we also see it. The beach, if you took away this wall here, you can just ask yourself, well, what would happen to that gravel? Where would it go? The question, and so Comar said he didn't say that there was no gravel, he just said it was negligible, which wasn't quite what others before him had said. One of the lines of reasoning he used was some data that was collected immediately after construction of the wall, which looked at what the trapping rate of this sink updrift of the wall was. And based on that, a number was arrived at, and that was the thing that convinced Paul that there wasn't a huge amount of gravel going around there. But that just was in the few years after the construction of the wall, and it was only a measurement done in the obvious place, close to the wall, because the wall's doing this thing, that's where the gravel will be caught. But if we look back down towards Tuki, what we see is the entire shoreline is rotated out. So this is like if you build in a stream a weir and then you increase the height of the weir, the water surface in the whole upstream part of the reservoir goes up, not just immediately behind the wall. So it works the same way here. The nice thing about this is that this is exactly how beach alignments work when Richard does his Unibest modelling and so on, where the headlands are and the effects that they have on trapping sediment allow us to come up with shoreline configurations in relation to those headland effects. So this is probably Paul wasn't privy to this diagram. He could have got this off the website, but these are just sort of pictures that tell the story in ways that he couldn't have seen. The other thing is we have these wonderful data from collected by regional council oversights this, and the two bold lines here just see, over the course of the data collection are from out here at HB12, just show that in net terms this is what's happened since was it 1970s that started? 74, I guess after the 74 storm was the impetus. So that's pretty much what's happened, mean trend since then, and I assume it's still happening. When Comar did his review, you might see some faint lines in here. He looked at those at the much shorter term fluctuations, which I understand because that's what he's more interested in. But it's not inconsistent with what I've just shown in the pictures. Question 5. We're going to stop after question 5? I don't have to, but they probably do. So I was somewhat concerned about stuff that Paul had said about the storms being responsible for everything. He made it a bit more complicated than that. He said it's probably due to the so-called interdecadal oscillation. Something to do with the fact that the storms come from different directions on an interdecadal from one decade to the next. And I was looking at the data that he was referring to in this, which was Smith's tabulated stuff, and I thought, maybe. So I did this, I plotted it up. I actually got the numbers out and plotted it up. And lo and behold, what you see here is more of a pattern that relates to the major events. So unlike the previous diagram of this type I showed, which was the changes from survey to survey, this these are the cumulative changes. So what's accumulating through time. So now we see much more variations, much bigger variations, which I can't even read on, so if I go up nice and close. So, I mean, the further we go back into the mysterious past, the more difficult it is to say anything until we get into the depositional record, but this is all historical stuff. My speculation here is, as you can see, the changes are all negative, so we're running out of volume initially. And I've written on here, depletion of harbour mole induced ebb delta sand feed. So do you understand what I mean by that? I said we had the first ebb delta collapse, and initially there was a big sand feed, but by 1920 that was running out. And by 1920 the British, whoever, refrigeration mechanics were starting to get seriously worried about their big shed that was built on this temporary land identified by Comar. Till we get through down to here, and about here they thought the jig's up, folks, and they pulled it down. We're moving. Went back to Britain or wherever they freeze things. But then, if they'd only waited another year, was that 1929? I think it was 1929. If they'd only waited a couple more years, they would have been as safe as houses because the land went up. And so this happens following the earthquake. You then get a renewed supply of sand off the ebb tide delta. And that ensues until that supply runs out, and then the whole process reverses and continues. Till we get down to the green dots. So this is Smith's compilation of data done by the Railways Department and other people. This is all the HB data series, and it shows that despite the nourishment that was occurring, well, let's get it right, that's 1990, so it only started in here somewhere, that as Gibb reported in 2003, there's still a net loss, just not huge. So that's just that last part zoomed in. So I would say we're feeling the effects of the uplift right through at least till 1970. What would that have looked like on the ground or on the beach? That would have looked like sand feeding off the ebb tide delta. And so you could go to the beach and it would just look like an Australian beach except for the colour of the sand, which would have been grey and brown instead of golden. And that's because of your tectonic settings, don't you know? Well, I won't go there. Paul did, he wrote all that up, but it's due to the tectonic setting. But eventually, just like happened many decades later, 50 years later in the case of the Columbia River, because it was a much bigger system with much longer time lags, it still took a number of decades for that whole process of sand feeding to come to an end. Well, it would have still been going on through here. It's just now that during this period of decline, well, I think it's a period of decline because there's this big gap in the records. Somebody must have retired, I guess, who was keen on going out and doing beach surveys. There's a big gap in the records, but it sort of looks like there would have been a trend through here. And all that means is the sand feeding became less than the alongshore reworking by waves due to alongshore sediment transport and longshore currents. It ain't rocket science, and so it's exactly what you'd expect from these events. It's just another diagram that says the same thing, only I wrote it in red rather than light grey, so it's a bit easier to read. So I could arrive at this conclusion because just instead of looking at the tables, I graphed it. I had to do some reanalyses to get there, but it gave me a clearer picture. It certainly slowed me down in doing anything. You could do the same thing with shoreline, so I won't bore you. I created a transfer function from volume to shoreline displacement. So it's not a direct measurement of shoreline displacement. I can tell you about that sometime if you're interested. It would involve some uncertainty. But they're not huge changes in the shoreline, but the trends are the same.
So from a public perception point of view, everyone talks about how it was a sandy beach when they were kids. If they'd been there in the pre-1931, it wouldn't have been so bad.
No, it's really interesting. If you'd been, in fact, it's quite clearly described by people like James Cook, well, maybe not James Cook, but you know what I mean. Originally they said it's a gravel beach, and that's what it is. And then they built the Hariri walls, and then it became a sandy beach, or sandier. After storms, it would have been gravel. Then after extended periods of fair weather, the sand, which found it harder to reside because it's finer and lighter, would start to build up. Until we ran out of that sand feed, then it was a gravel beach again, right up until the 1930 earthquakes. In fact, there's one source that a geologist that was at Marshall walked the beach immediately after the earthquake, still said it was gravel, and therefore, you know, the earthquake can't have been responsible for making a sandy beach. That's because nothing is instantaneous when it comes from sediment transport. It took, as I've showed, decades for the sand to come on shore, so it would have taken years for it to arrive at the beach. But from well past 1930, and Larry's shown me pictures of sandy beaches, you know, right up until around certainly the 70s, maybe 1980. You'd be able to address that. Larry, like me, is old and so can remember these things. Is that it was sandy, but now it's gravel again. Well, partly it's gravel because he put gravel on the beach, but it would cease just like it did eventually after the construction of the Hariri walls. It would have gone back to being gravel, just like it's supposed to be in the absence of other interventions and disturbances. I can imagine what that might be. That very nice lady warned us what to do in the case of an earthquake. So, you know, anything's possible. It could be sandy again. Well, we're going to stop, weren't we?
Yep, so morning tea's...
Morning tea.
Afternoon tea. Afternoon tea's on its way out.
Well, I'll just continue on this. It'll give something to think about over lunch, maybe. So, part of my brief, which I was asked to look at, was what would you do? What are your recommendations? And everybody's made recommendations, so I huddle up in the corner in the fetal position and say, please don't ask me, because you've got plenty of other recommendations from people who are at least as smart, and I'm pretty sure in some cases a lot smarter than I am, so I'd prefer to say nothing. But anyway, here we go. My recommendation is completely contrary to, well, it's not completely contrary. I mean, in fact, the experiment's already been run on this as well. Dump ground R, Gibb, 2003. It's even been measured and reported. Jeremy didn't say, well, the dump ground is responsible for stabilisation of the coast, but he speculated that there was he said there was a correlation. I mean, coincidence. Might have been a coincidence, but there was. Well, this is actually the one and only thing that I'm actually good at in my scientific field. So I'm regarded as being something that's almost irrelevant to other people, but at least I can do this bit properly. And that is to work out what happens to the seafloor when you get major changes in what we call boundary conditions, don't you know? That is, sea level changes, or you change the sediment supply or loss regime that the coast is under. And so, I only know about this because I read it in books and stuff. You know, other people have spent a lot of time looking at geological records, you know, that down cores and dating it, and I've had the privilege to work with some of them. So we know it's happened in the past. We know it happens when there are relative sea level changes, and we know what goes on with sediment supply over the geological term. By geological term, since physicists tend to vacate the field after about a couple of decades at most, this is multi-decadal to millennial timescales. Several decades, many decades, through to thousands of years. Geologists really take over after that, over super long timescale. We can work for thousands of years because the ocean has really only been at this elevation for around 6,000 years. And so we've had pretty stable conditions with respect to sea level change to give us some handle on what's going on. In other places where the sea level is changing, we can see what the responses have been by looking at depositional cores and so on. So what happens when sea level goes down or the land rises? It becomes too shallow and we get a sediment feed out of that, as I've already described. What's been happening and what the HB data is showing, and Larry was the first one to point out to me by looking at the Harbour buoy, no, it's not a Harbour buoy, it's the freezer work boiler stuck in the beach at Westshore, is that the beach has been, not the beach itself in particular, but the lower beach and subtidal beach is being lowering over time. When he first showed it to me, I thought, oh yeah, Larry, you've got an axe to grind, and maybe you just found the pictures that tell the story, and if you'd gone back 2 years later, it would have been completely buried. But anyway, turns out the HB data vindicate him, so it's, this is what's going on, is if you stand on the beach and you look at the boiler or you look at the HB data, then the surface through time, let's say at about this point where the boiler might be, this is the intertidal level, but it's actually probably further up here, the beach has been going down progressively. So we have, this is obviously a concept diagram, this is not a survey, or those data are available, but I haven't cartooned it here. So it goes down through time, from here down to there. That's exactly what you get when the coast recedes. And that's what these curves are. I'm saying the nearshore zone used to be out here, the subtidal beach going out to way out where the port is. And this whole part of the seafloor has migrated in the landward direction. And theoretically sits under that ridge, that nice ridge of gravel that's been put there by put there as protection works. So often you look at these sorts of changes, and this is my contribution to the science, is what you see through time in one place is related to movements in the horizontal of these depositional surfaces. We use it in the oil industry, for instance, to be able to explain how the oil reservoirs form up through time and so on. So it's been pretty well road tested, including with coastal scientists throughout the world. So we're pretty sure the way this works and our depositional records tell us. So although it looks like the thing is lowering, it's actually moving, the whole coast is moving in the landward direction, which is where it wants to go because it is too far out to sea. So but what it looks like to us is that it's lowering through here, when effectively it is, but it's moving as well. The kinematics of the submarine beach. So what Comar did exclusively in his report was to concentrate on this bit. Well, the shaded bits are my cartoon for adding gravel to the beach to keep it there. And the point that he makes is that, well, you got to use gravel in the nourishment because up here on the upper beach, sand is not stable, and that's something I totally agree with. And the thing I would further state is that if you put Dolos blocks up here, huge, great lumps of concrete or even boulders, it'd be even more stable. But if you want to still have sort of finer sediments, coarser gravels will make this more stable but less fun to be on as a recreational coastal user. The trouble is, the whole attention has been in the HB surveys, except for some which thankfully go right offshore, but certainly in terms of the management thinking, has been what can we do with the beach face? And Comar's dead right, you can only use gravel, the coarser the gravel, the better. However, one of the things I know he knows, because he's published our work in his books to the same effect, is that this part of, because the POMs dominated the early scientific enterprises in this area, and they didn't like to get their shoes wet, they focused exclusively on the dry land. And our big contribution when we were asked by the US Navy to work out what went wrong with D-Day, that was where Private Ryan's mates got bits blown off, shot off, was we came up with, rocket science it was. Well, maybe what's out here is connected to what's in here. The two things are part of, as far as nature's concerned, the same thing. And so that's now well established in the literature. We weren't the only ones to do this at the same time, but that's now the conclusion, which, as I've said, Paul's helped us publish, is that the dry beach and the submarine beach are connected. You can't deal with them as separate entities. And once you know that, well, we can do things out here that affect what's onshore. And one of the interesting conclusions you can immediately draw from that, well, what sort of sediments live out here? It's sand. And so you can actually nourish the beach out here with sand that you couldn't keep on the gravel part of the beach. That is in the run-up zone. Unless you added so much sand that you just flooded it like happened after the earthquake. So the earthquake resulted in the flooding of the nearshore zone with way more sand than was, that is the uplift, than was typically the case. So in principle you could put in a lot of sand and make a sandy beach again. But just another way of providing this sort of coastal protection is to nourish the inshore. So that's completely consistent with general principles. It's completely consistent with my lifetime research and that of the people I work with. And it's completely consistent with the experiment that was run with Dump Zone R. That was, Dump Zone R was, once upon a time, the port did some dredging, as it always has to do, to maintain shipping channels, and some of the dredge spoil it put immediately off the beach up near north of Westshore, or northern Westshore, an area called the Esplanade. And that we talked about that a little while ago, is that it all looks hunky-dory up there. It may be nothing to do with the dump zone, dump ground R and the sediments that were put there, but I think on the balance of probability, given that it's consistent with what we know with the science, then it was an experiment that came up with a nice precedent of a way to manage it. My afternoon tea must be ready now before I go on with this. Yeah. So the question number 6 was, what is the nearshore deficit? And I suppose in part that's come out of some very brief comments that I've made in the last few months, that there is a nearshore deficit. And as I mentioned earlier, I was alerted to this possibility by Larry Dallimore, who's taken a great interest in it, as many of you may know. And as I've indicated, was not at all unexpected for me, because the general principles in my science would tell you that after you have some sort of disturbance like an earthquake or a building of harbour walls, you'd get a collapse in the ebb tide delta that would lead to a short term, and by that I mean over several decades, surplus of sand in the near shore, so it'd be way more than you'd normally have, but that would bleed away because of the effects of longshore transport. And so somewhere in that cycle, what looked pretty good, in the Westshore case that was sandy beaches, would eventually start to look like there was a deficit. So the nearshore deficit must be seen as part of this initial response to the earthquake flooding the near shore due to the uplift, the near shore with sand, and subsequently it relaxing or heading back in the direction of normality, which is with the near shore lowering and getting back to something that was more like what it was pre-earthquake, and for that matter, pre-Hariri harbour moles. And the one big fly in the ointment is that in the meantime, there's been a whole bunch of real estate subdivisions and so on. So Wayne wanted to know, therefore, how important was it to address it, this nearshore deficit. Well, I have my views and other people have theirs, I mean professional views, and I'd have to say, before answering this question formally, There's a fair bit more work that needs to be done, so I'm sure Richard would be rubbing his hands together on this basis, and his colleagues. The sector there, the technical advisors are absolutely crucial in being able to evaluate, as they've been doing for quite some time. And I know many of you get frustrated with it, but they work within their budgets based on the questions that they're asked and so on. And if there was a simple solution, well, I guess it would have been found by now. This particular, well, I hesitate to say this because it's almost a universal truism, but this is a complex part of the world. Everywhere has training walls and collapsing ebb tide deltas and so on, but not everywhere has the ground go up by a metre or more, or down, depending on where you are along this segment of the coast, which is just absolutely wonderful for an academic such as myself, because it's like a natural laboratory, but to actually have to manage it. As a scientist, for me, it provides the opportunity to learn about new general principles. But you've got to know the answers now, and the fact that it's taken so long to get answers just reflects the complexity. To every complex problem, there's a simple answer, and it's invariably wrong. So thankfully, this process is ongoing and will be for some time to come. However, what is my professional opinion based upon my now many years of experience working in these environments and rubbing shoulders with the Paul Comars and pretty well everybody there is to know, and there's not many of them, but you meet up at conferences and all those sorts of things. Based on that, I would say that my best recommendation, subject to further investigation by others, would be that the submarine beach is pretty critical. Even if you don't want to do anything very differently from how you're currently doing it, that is applying gravel as a remedial measure to the beach face, sourced from who knows where, anywhere you can get it, and I understand that's getting harder and harder. Even if you want to do that, that will become much easier by doing nearshore nourishment as well. And why that will be easier, I mean, the people who do it, they use ships to do it of various sizes, and they're mostly Dutch. They can build islands that look like palm trees if you want them. You want an island that looks like a palm tree? Just ask Van Ords or Boskelder or someone, they'll do it. And the other thing, I went to the trouble of getting out the geology maps for the offshore, and what they say, as far as I can work out, but should go and ask the people who did the geology maps, it turns out that's Jeremy Gibb as well, one of them, is that there's a lot of sand out there. And unlike in where I come from, New South Wales, where it's against the law even to look for sand offshore, I've heard that New Zealand already takes its sand haul away, so they can have sandy beaches where they'd otherwise have pretty nasty black sand, or at best otherwise boulder beaches. So you've got the resource as well, and so in principle the logistics of it is pretty feasible. Just got to add money. That's the difficult bit. What will happen due to the proposed construction of the shipping channels? Well, it's happening already with the old shipping channels, and will continue to happen. The port's going to have to continue dredging from time to time. If you bring sand in from far afield, that's going to be even more sand that's currently in the system, as opposed to just the stuff that the port is having to dredge out anyway. So they'll have to dredge more often. If they use the sand out of dredge channels, they will have to dredge less often, but they'll still have to dredge. Even if you don't put sand in the near shore at Westshore, the dredge channels are still going to get sand in them, because by dredging a channel, it creates a sink, and the sand that's going to fall in is the sand that's already there that you didn't dredge right next door. So that process is happening. Without it, the submarine beach is probably going to continue to lower. I say probably because I'd have to look at it further from my point of view to see how close it's got to re-equilibrating with how things were before there was an earthquake, but for that matter, before there was a port. So the fact that the sand is still coming, but it's not coming the same way as it was, it ain't a simple problem. One of the things that's impeded me in doing more work on this is I've been doing advising and reporting to the Australian federal government on what's going to happen because of climate change, sea level rise and change in the longshore transport as the weather changes with climate change around the coast of Australia. There's 24 million Australians and it's a rather long coastline. But Australia actually really needs to answer this question because it is a coast that's got areas that are not subject to risk at all and ones that are subject to greater risk, and we don't, well, from a government's point of view, haven't really identified which ones are which. It's pretty fundamental. Now, another bunch of nationals I work with are the Dutch, and you all know what sort of problem they might face with sea level rise. Paradoxically, even though a third of the Netherlands is below sea level, if you've flown into Schiphol Airport and flown out again, which is mostly what people do, it's 12 metres below sea level. What do the Dutch think about climate change and sea level rise? Well, they take it fairly seriously, and they dole out money to people like me and my mates to waste on our self-indulgence, but they don't care. They're going to deal with the problem regardless of what comes out of the science. They've done one important piece of research. They found out that the part of the North Sea they own, part of their jurisdiction, has enough sand in it that they can raise the height of the Netherlands by 5 metres, which they have now decided they're going to do. Well, actually, it's only the third of the country that's at sea level or lower. And they're not doing it so it'll be, slightly above sea level when the Great Flood eventuates. They're going to do it so they don't have to pump water so far uphill, because there's only so much you can do with windmills and clogs, right? And water's rather heavy. So that's their real objective. And they've even worked out if they start doing it now, by the time sea level's a metre higher, they'll have to move less sand out of the North Sea into the Dutch lowlands than they currently do to build highways, because they're currently doing it to build highways. So the secret in that is if you start early, it's feasible. If you leave it to the last minute, not only will it cost too much, but you won't be able to do it anyway because there'll be too much to do too quickly. So they've already squirting sand onto their beaches, and the logistics they face are way worse than the logistics here, which is in a harbour, because they have this very, very shallow offshore gradient. It's just the water goes out at a few metres depth for it seems to be over the horizon or till you get to England. It's just an amazingly shallow seafloor. But they have these huge ships that dredge the sand up, and they come in as far as they can get, and they've got these cannons that squirt the sand out into the near shore, and they let the waves do the rest. So this isn't anything new, it's something that's already being done, and that's how they're not going to build dikes. Well, they might build some dikes, but mostly what they're going to do is nourish the near shore. The near shore will nourish the beaches, and they're quite happy with the idea that while the rest of the world's going under, these people who are used to living in the lowlands will survive. Even if you squirted this sand inshore or did any of these things I talk about here, you still need to do something with the upper beach. My professional feeling is that if you nourish the near shore, and if you did exactly what you're doing now, you wouldn't have to do it as much, you wouldn't have to do it as often, and Dump Zone R gives some sort of experimental evidence that that's actually the case. You don't need to pay as much attention there once you've nourished the near shore. But, it's something that you'd have to continue to do. And that's pretty much the same everywhere with everything in society. Probably in Napier, your stormwater and sewage system needs tweaking as well. And, why do I say that? Well, everybody's got that problem. There's maintenance is an ongoing thing. So Wayne also asked me about what are the other options, and they've been canvassed by others already, and from what I've read, I'd say they're preliminary assessments by and large, but they've been quite sensible assessments. Specific proposals have been put forward for different sorts of walls, and some issues have been found with them, and there's been, you know, quite a few, I think over 6 designs for different seawalls, configurations, small scale things along Westshore, and there's always been some problems. I think you probably need some bigger thinking than just the odd bit of tweaking. I mean, that's been happening. I think it's been working. Komar said, he concluded after all, that it's been working. Some people, like Larry, thinks it doesn't look pretty, and I'm sure there are other members of the community think things should be done better. But you know, Westshore's still there for the time being. But to find real solutions, I think it's necessary to expand the scope a bit. Anyway, so the real solutions have been canvassed, or the pragmatic short-term solutions have been canvassed, and I would add to the mix this nourishment of the lower near shore. Part of the problem is that the value of the assets there aren't particularly great. I mean, I don't include the port in that because that's, you know, it's a sacred cow in all of this. Nobody kids themselves that the port can be anything but enhanced for the future of the region. But at Westshore itself, the value of the assets are modest. So one of the options is to do nothing and let nature take over, and the losses won't even be noticed. I mean, if you go back to the decision making in the days of building the Hariri training walls, future generations will be as unaware of the loss of real estate at Westshore than as most people are about what happened with the Hariri training walls 100 years ago or more. So that's definitely an option, is to do nothing, allow nature to take over, and have coastal retreat. In many places, like I said, in the UK, this is the preferred option. Most places, you've got to come up with a greater justification if you don't want to do that in the UK these days, simply because it's such a huge burden on everybody else in the community to actually keep on funding this stuff. So they're a bit freaked out by it, and so they've tried to stop doing it. So I kid you not, it's a real option. And I can understand why some people would think it's not one that they would like to see happen. Seawalls are an option, and you know, engineers can pretty much do everything these days. Have you seen those films of Elon Musk landing rocket or his research program? It's easy enough to blast off a rocket, but now they can bring them back and land them, at least the boosters, where they took off. I mean, you can do anything, but you just got to be Elon Musk and add money. So money is the big issue. I've been around this business for so long now that, except if you're going to build, say, a runway into Botany Bay to expand Sydney Airport, and they built a seawall to do that, notwithstanding that it's actually below design specifications for sea level rise, so they didn't even get, you know, cheapskates cut the corner on that one as well. Usually what happens at beaches, though, because of this bit, low to moderate asset values, first the engineering design will be, well, can you guys do it a bit cheaper? So these days what they do is risk assessment. So there's a design life, typically 10-year design life. And if you get outside 10 to 20 years, they start to get really, really expensive. And in addition to that, now you have to take into account sea level rise. And what happens with sea level rise, as I showed in my profile diagram, the seabed retreats inland, the ground goes down, and what's sitting on this ground? The seawall. So they have to be engineered to take that into account as well. Generally what happens with these seawalls that match asset values or might be a little bit beyond them, then they get built, if they get built. And what happens is they hand the building over to earth-moving construction contractors who seek to maximise their income. Sorry, Larry, I don't know, that was Larry takes all this seriously, so I know he wouldn't do this. He's pointed out to me all the bad jobs that have been done around the place. But he's dead right, is that when these walls get built, they're almost never, except in the case of runways for the Sydney International Airport, they're never built to the engineering specifications anyway. And they fall apart. It might be a cheap one going to last 10 years. In fact, the last one at Byron Bay that I was commissioned to review and said, well, it'll never work because this is what happens when people build seawalls. They built it anyway. The judge said, oh, well, they can build it. And it didn't even last 6 months. And Byron Bay, it is just tourism mecca. Tourists go there because they like the beach. Now the beach is strewn with rocks that the tourists, of course, are at serious risk of injury. And, in this litigious society, that has blowback as well. So I very much doubt whether a seawall can, in practical terms, be built that's expensive enough to work and be paid for and not become more of a problem than it is a solution. So I'm not saying it can't be done, but my experience and feeling on the subject is that it's not the first solution you'd go to. You may go to some partial seawall solutions as part of a much grander design. To do it properly, you need a 100-year design life. And I'm not an engineer, so I don't know how much that'd cost. But I, been around these people, and they tell me it costs a lot of money. And even then, there's going to be maintenance requirements. There's never not maintenance requirements. It's much easier to work with drag lines and excavators on sandy or even gravel beaches than it is off something that's become a rocky coast with what constitutes sea cliffs. The other thing that I put on this list now was about, well, I'd like to see, if I was interested in this, costings done on all these things, cost-benefit analysis, that sort of stuff, but including on dealing with the submarine part of the beach as a way of solving the problem. But I would also suggest that it's done in the context of a much bigger picture. When I've been asked by the Australian government to evaluate what liabilities face the nation in the context of sea level rise and changes in climate, so that includes the effects on waves and longshore transport and so on, in the future, they only ever want to know what the consequences be for Australia today. That is the Australia with 24 million people, with greenfield sites and brownfield sites distributed as they are. And climate change happens really on the centennial timescale. That's what you need to plan for. And on that timescale, Napier, if you think back what Napier was like in 100 years, you don't even have to think about it. You can go and look at the pictures. They're just fabulous. But it didn't look anything like this. I suspect even a few decades ago, much of Napier as we see it today was just cow pasture and so on. So there's no point in drawing up plans that simply look at the here and now. So one thing about the asset base being modest is it won't stay modest. After Larry and I have gone, there will be richer, more successful people. It may be that if you did this nearshore nourishment, Larry's dreams would come true and the nearshore would be flooded with sand enough to have, for a significant, maybe not all the time, but a significant proportion of the typical year, a sandy beach that the citizens of Napier, not to mention the even larger number of tourists who are larger than the number of citizens in Napier that visit the place and inject their money into the economy every year, would also like to use. And then, of course, once you start thinking in those sorts of terms where the sandy beach is, we build things like Byron Bay and resorts and so on, and so might you. And thinking that way into the future, you also have to factor those sorts of things. It would be advantageous to factor in the demographic, socio-economic parts of the future into doing the cost-benefit analysis. Anyway, the technical stuff certainly has to be part of that, but only part of it. And I think the scope really should be expanded. Then the idea of nearshore nourishment really takes on a different complexion. And I know some people concern themselves about who's responsible for all of this. I mean, from an outsider, there are assets in this community, both natural and commercial assets in the community that everybody shares in. So it's a community level problem, and I know you've set up community-based panels to consider these problems, which is, I think, groundbreaking in many ways. It has happened in other places, but what's being done here is exemplary in that respect. Everybody shares the problems, and everybody looks for the solutions. Won't get perfect agreement, but hopefully a consensus will arrive out of that. All I'm doing now is repeating the words that Paul Komar concluded his 2004 report in. So, question 9, which says finally, so it must be the last question. Can the place become a sandy beach again? Well, you've heard why it's been a sandy beach in the past. In previous visits, I've been told, no, it never was. So it depends on who was looking at the time that it was or wasn't. But if you look over time, it most assuredly was, and so there are pictures of it being a sandy beach. Things used to happen here that can't happen here now when it was a sandy beach, surfing competitions and so on that require sandy beaches. So the possibilities have already been experienced by nature, by Napier, and it certainly can happen again. It can happen in two ways. One, it can be quasi-permanent if there's enough sand applied. That has to be done in strict consultation with the harbour, because it's always you have this problem, too much sand if you run a harbour, and everyone else is saying not enough sand, but so that has to be a joint effort in solving that problem as well. And there's an intermediate situation where sometimes it'll be sand and sometimes it'll be gravel, depending upon whether it's a stormy year or several years without storm, so that it'll be less nearshore nourishment. I won't deal with those other things. They're more from my background, but backgrounding me. I'm somewhat, as I said right at the beginning, reluctant to say those sorts of things. I only say them because I've been asked, because I am aware that there's been quite a number of people make recommendations, and sure enough, Cowell turns up from that place that's the rugby enemy, and comes up with yet another recommendation. And so I can see the dilemma. I mean, how many recommendations do you need? I mean, at a certain point, another one is just problematic. And I fully appreciate that, so I offer it up in that spirit. Anyway, so I'm happy to take questions on any other subject, excluding rugby, because contrary to my last observation, and Matthew's gone now, so I can say this, I don't take a particular interest in it. I'm more interested in the surf. Oh, I should say one more thing. Larry's pointed out to me when I said, flood the nearshore with sand, Larry, don't build a wall. He said, the surfers won't go for that. Well, I'm a surfer. I do it every day, or twice a day if I can get away with it. And I've already mentioned this thing on the Gold Coast where the sand pumping to solve what was seen as a completely intractable problem, coastal management problem, that had states suing each other in the federal court. Well, that's how much conflict was involved over it. And it not only in the end resulted in a solution being found, but has turned one of the antagonists into a site that's desired by all the surfers on the planet. So adding sand to a beach does not necessarily result in inferior surf or a loss of surf. It can actually result in the best surf breaks on the planet. And you've even got people here who've set up businesses on that basis. Kerry Black's dipped out now, but Shaw Mead, his protege, is still there, so you can ask Shaw what he thinks about making a super bank. So I'll be back if there's a super bank off Napier in my 3mm wetsuit.
What do you think about
Well, that's one of the things that needs to be done. You'd be surprised at the grain size difference between the beach face and the offshore. It gets fine very, very quickly. One thing is about our textbook view of beaches is that, and I'd say it's a textbook view because it doesn't apply in all cases, but the general idea is that you start off with coarser material in shallowest water and you go through progressive fining all the way out till it turns into mud. And at that point we say it's nearly not really part of the beach anymore. And as I indicated earlier, that's in around 40 metres of water in this sort of wave climate. So it gets out to very fine sand. And what we would say is a big mistake, particularly on the time scale and in the context of climate change, for ignoring the sand in deep water, because in many places, including probably here, that's one of the sand feeds. Although it needs to be evaluated, it's one of the things I started looking at a couple of months ago because there's some data on it in Comar's report. It needs to be looked at, but what is too fine is well, I say questionable, but it may have been done by now because I haven't looked at anything for any of the more recent work the port may have done.
Kerry Blacks and ASR when they did their study, measured about 48 samples and ranged 100 to 150 microns was ranged in that unusual area, so out to about 2 metres there.
So it's not real coarse sand, and yeah, and that's what you'd expect. Winnowing would take effect, and that's what you'd expect if you just go out onto the inner shelf and get funords to pick it up and bring it in and squirt it everywhere in the near shore. And what'll happen is then, this is what the Dutch do, they just let the waves do the rest. So the waves will then sort it, just like you would do in a commercial process. They'll sort it into size fractions and it'll be redistributed by nature in the way that nature likes it. In fact, the Dutch now have this sort of philosophy or a protocol, and it's actually a protocol that they apply with their coastal engineering, which is design with nature. So they wherever they can, they get nature to do the work, and also they come up with designs that look more natural. So a fundamental question always is, when there's been some major disturbance or change in a coastal system, but certainly any principle works the same way most places. When you look at a coast and there's been a big disturbance and you want to know how you can fix it, first thing to do is ask, what did it look like before the disturbance? And I know, things have got significantly messed up here because of the earthquake and the uplift and so on, but the first approximation to this is to ask the question, well, where was the beach? And you can just drive out to Westshore and there's this big pile of anthropogenic gravel sitting there, and then further inland you see where there's a beach face. So we know where the beach was, albeit it was lower and now it's raised. But that at first approximation, that red line in the Worley-Becker map that I showed is there, probably. You could do a bunch of unibest modelling and so on to test the hypothesis that might be it. But that'd be the first best guess. And in the meantime, you have tried to maintain the whole shooting match way out of equilibrium. And you're paying for it. Every time you do it, every time you levy rates, and every time the government hands over loot to run regional government, I assume they do that. No?
So are you implying that the sand of the fineness that Richard just said is usable?
Well, I'd say ask Richard, because I haven't actually looked at the sizes, but you could expect that the fine sand would find its place somewhere in this seaward grading in the sediments. And if you put it right in near so if you dredge sand up, you probably get a whole mixture. And the way the sorting would work is the finer stuff would move offshore and the coarser stuff would move onshore and it would sort itself out. But the reality is you need all that sand right across the entire shore face, or near shore, to have a viable, stable, in terms of long-term averages, beach. The beach is not just the part that us monkeys walk on. We're terrestrial creatures. But the beach actually doesn't care about us monkeys. It connects up with what's out seaward, and everything is connected to everything else quite strongly. We've actually written papers about this, the coupling from the deeper water part of the beach into shallow water. When I say deeper water, I'm talking about out to 40 metres. It's quite strongly coupled. The time scale is the issue here, but you're already on a time scale of disturbances which is the same. That is the centennial one, many decades. So if you don't look at what's been happening over many decades, you'll never find the solution here, because that's what is required.
So could the sand that's being dredged up from Napier, would that be used for that?
Well, I can't say definitively because I haven't looked at the sand sizes. Richard probably has a better idea of that, but I would say in principle it probably is subject to further work. And I know that sounds very frustrating to people who have to find the money and wait and do all those sorts of things, but it's the only way you can be prudent is to it's actually the further work is quite cheap compared to actually doing the job. So it's money well spent, must be spent. So the answer to the question is contingent upon that, but I'd say in balance of probability, yes, it's appropriate sand. Well, it could. Well, I don't know. So it sounds like a big hole, but there's a lot of sand out there, not just in the shipping channel. And if this became a significant enterprise for the city that went beyond just protection of Westshore, but looking at in terms of what value adding can be done along the way, what opportunity. There's a problem here. So what are the opportunities to be gained out of the solution? Not just fixing it, but what opportunities do we actually have to make the whole place work better? Then you can start asking different questions about how you fund it. And I know this from working with federal politicians in Australia who are, just mad as cut snakes. You can't actually talk about the problems. They don't want to hear about the problems. They just want to hear about how to make a buck. But in reality, that's just semantics, because every problem has its opportunities. And Napier is a fantastic example of this principle. I mean, poor old Napier. I mean, to start with, if you look at some of the old photographs of what the first settlers thought was a viable place to settle, you would have had to say they're out of their minds. It's a swamp. The only place you can build is a beach and a hill that's so steep and useless. They did it anyway. Good Scots and Poms and so on, they weren't going to be stopped by that sort of stuff. And then they had floods and earthquakes and you name it. And they've built out of that, and out of the natural disasters, a complete success story. So I can't believe that something as small scale a problem as what to do with Westshore can't be turned into a large scale opportunity.
And therein lies, I guess, the opportunity, but also the challenge. So I think we just need to. The issue we've got, as you said, no matter what expert you bring along, they're going to give you a different opinion as to what the cause is. And I think as long as we can all agree there is a problem, there are a number of factors which have caused that, but more importantly, what are the opportunities and the solution? As long as we can all agree on that and how we manage that, I think that's what we need to be focusing on.
Yep, and that's what Cowell said more or less at the end of his incredible tome that he wrote, that they were his concluding words, and I can't help. Any sensible person I would think would agree with that. I would add to it that I can see why you might get frustrated. Like there's 3 people in the room probably that have read Cowell's thing from cover to cover, because it's a daunting task, and even complete nerds like I am, it's still a challenge. For everybody else, it's a paperweight or a doorstop. But so I can see how it can be frustrating that someone can turn up and write so much, and then at the end of it, I turn up and say, well, you've got to do more work. But unfortunately, it's a complex problem. Cowell's done the great service of reviewing all the work that's been done so far, which made my job of looking into it, along with knowing what Jeremy Gibbs had to say, a lot easier. So, it's a very valuable document, and I've come to different conclusions in some respects to the ones Paul came up with. And in the end, it may well continue through to crunch time when somebody really does have to make, well, there's pro-tem decisions have already been made. Like Comar, I reckon it's been well managed so far. But it's an interim management thing, and nobody kids themselves that really, is this what we want to do for the rest of, well, not just our lives, but for the rest of history? I mean, what else can we do? And in the end, the community are going to have to make that decision based on advice, and it might be several recommendations which are completely antithetical to each other. The community or their representatives are going to have to arrive at a decision which involves biting the bullet. But I'm sure there is good things that can be done. I've never seen a case where it's not possible. Have you had the Dutch involved? Richard's worked with the Dutch. I guess you're a proxy Dutchman. There you go. So as I said, they have this protocol of design with nature, and that's in a broad. It sounds like just some sort of easy thing to say, but the sense of it is, I think, valuable, and they've learnt the hard way. I mean, they've come up with many solutions after making problems that they've of their own making, but eventually, in the end, they've decided they'll work with nature rather than against it. As the world's greatest dike builders, that's quite a distance to have travelled. Yeah. No, it's dependent upon the wave climate. So if the bigger the waves, the deeper it is. And your wave climate, like Sydney's wave climate, is a pretty moderately powerful wave climate. So many other places will be much shallower, and some places a lot deeper. I mean, the sediments will be disturbed, the sand will be disturbed right across to the edge of the continental shelf here sometimes. But in terms of the geological indicators, modern muds that have been deposited under present day conditions are a real indicator of where the wave effects become weak enough so that they can be ignored. We know from the research we've done that a lot of the sand that's presently in our dunes and on our beaches has come from as far out as, but no further than, about 40 metres water depth. Incidentally, Marcel did the same thing in the Netherlands. So the Dutch have done it and found, despite the fact sea level's been going up there at the predicted rates for global sea level rise that we face in future, it's been doing that for the last 6,000 years in the Netherlands. Their beaches and dunes look a lot like ours. They've built out by the same amount. So it tells you, and the Dutch engineers are applying sand to the coast in the same way, that even though you've got sea level rise, doesn't necessarily mean that beaches are going to disappear. And in fact, they can still keep growing if there is a sand supply.
Peter, if you do the sand pinch, or bring the sand, dredge sand, would you eventually be able to do without the heap of nourishment made of sugar?
Well, that's sort of in one of these questions, could you turn it into a sandy beach? And that's what nature did after the earthquake. In principle, the answer is yes, but you'd have to do the cost benefit on, how valuable the tourist industry is, and what are you protecting, and how much does it really cost? And that would be all after the questions being answered, like, do you have enough sand out there? Looking at the maps, I'd say yes, but I don't know what the laws are and don't know the quality of it. So there's a way to go, but in principle, yes. And of course, the port would have to be consulted about this, because ports and sand don't go together real good. So, it has to be something that's mutually worked out.
Is that the Gaia? Is that with the Gaia?
Well, I don't believe in the Gaia effect, really. I believe it's a big washing machine. But, okay, a Gaia is part of the eddying around of sand. And even if it wasn't there, the sand would be moved in different directions almost at random over time, with different storms from different directions and different currents associated with it. So the sand's going to get everywhere. If you've ever been for a swim at the beach, you know the sand gets everywhere in all sorts of unspeakable places. Quite frankly, you know, I spend every day, if I can, in the ocean, but I regard a beach as something that is an anathema. I always prefer to find some rocky outcrop to jump off so I don't actually have to go over the beach because of this problem of the sand getting up your wetsuit and all sorts of unspeakable places. It gets everywhere, and there's no way to stop it. If you've got sand, you've got little beaches in town now, when there's storms, the sand will end up in the car park and on the boardwalks and that sort of thing. So the biggest post-recovery disaster actions that are taken after storms in Sydney is with front-end loaders that shovel the sand out of the car park back onto the beach. You know, it just gets everywhere. If you can do it without sand, it might be the seawall solution, but anyway, I can see why people like sandy beaches. You even have photos of Westshore packed with people, just like Bondi Beach once upon a time. So I suspect I'm in a minority here.